My name is Brent and I am the chair of the Department of Civil Engineering at the University of Toronto. My area of research is groundwater remediation, cleaning up contaminated groundwater. We're primarily looking at remediating groundwater and soil that are contaminated by organic compounds, a lot of industrial organic compounds, hydrocarbons, things like diesel fuel, gasoline, and chlorinated solvents, things that are used for degreasers in industry, even things like dry cleaning solvents that people, when they take their clothes for dry cleaning, are used to clean their clothes. My research is funded by a variety of sources. Some of those sources are government sources and others are industry sources. We have quite a lot of collaboration with industry. We have a large project. It's a 5-year, $3.2 million project that's funded by the Ontario government through the Ontario Research Fund Research Excellence Program, the Water Round. But the key to getting that funding was to have industrial partners who support the research and interact with the researchers and the students. We have, in that project, we have 4 companies that are supporting our research. So they come to our annual symposia, they provide us access to field sites, they interact with the students, provide us feedback on the research that we're doing. One of the projects that my students are working on is the use of nanoscale zero-valent iron for remediation of groundwater contamination by chlorinated solvents, things like dry cleaning solvents. And the reason we want to use nanoscale zero-valent iron is it's very reactive and it converts those harmful chlorinated solvents to harmless byproducts, primarily CO2 and water and chloride. We're also looking at how the interaction between the nanoscale zero-valent iron and the indigenous microorganisms in the soil, which also have some capacity to degrade those contaminants. And we think there might be a synergistic interaction that the iron will reduce some of the contaminants and then provide conditions that are conducive for the bacteria to complete the degradation. The issue of sustainability has come up a lot recently in the groundwater research area because some of the groundwater remediation methods are quite energy intensive. For example, one of the techniques is electrical resistance heating, which consumes large amounts of electrical energy to heat up the subsurface to boil off the contaminants. So we have to weigh the impact of the energy consumption associated with this remediation technology against the impact of cleaning up the contaminants. And there's always now, many companies are actually doing a sustainability or life cycle assessment of the technologies that they are applying to. So it's one of the criteria that's used in selecting a remediation technology. And in fact, the US EPA, the Environmental Protection Agency, has developed a primer for remediation companies to use to evaluate different remediation technologies with respect to their environmental footprint. I think what I get out of it is that it's a great department and I have an opportunity to represent the department in the university and help to make sure that the department prospers. This is a great department. We have many of our faculty who are internationally recognized for the excellent research that we do. We have great graduate students who are doing very exciting, innovative research in a wide variety of areas that are relevant to civil engineering and mineral engineering. And it's an exciting place, I think, to be a graduate student.